we're given that a second derivative of a function f of x is all this stuff. That means there is a first derivative. We don't know what it is, but if you were to take its derivative, it would turn into second derivative. We can kind of use the power rule in reverse, right? If there's an x to the third power, and we're trying to imagine what the derivative was, what the function was before we took the derivative, then it's got to be x to the fourth. Because when you take a derivative, the power comes down and reduces by 1. And same thing here. For this term, we know there's got to be an x to the second power. The coefficients might be the tricky part. And then this term here, we know this has to be something to the first power. Because look, when the derivative comes down and multiplies, it gets reduced by 1. The derivative comes down, makes that comes down, multiply, and it gets reduced by 1. The derivative happens, and then we just have a constant. Okay, so we know that's supposed to be our exponent. To figure out exactly what's supposed to go there, look, this term, when we take the derivative, we're supposed to have nothing here in front. So we got to have a 1/4 that when the power comes down, multiplies, cancels out. And then here we need to have an 8 left over. So when we take the derivative of this term, a 2 is going to come down and multiply. So if I stick a 4 in front of there, 2 times 4 will make 8. We're supposed to be left with a coefficient of 9, so let's stick a 9 in front of there. That way when that 1 comes down and multiplies, we still have the constant of 9. Then look, this is our first derivative. But I'm going to put plus c, okay? Because we need to figure out what this constant c is over here. Because look, if you take a derivative of this right now, it'll turn into this. If I do a plus 1, or a plus 2, or plus 7, or plus 5, or minus 3, or minus 7, if you take the derivative of any of those with plus an extra constant at the end, it's also going to work. There's an infinite amount of first derivatives that could turn into the second derivative. So that's why they gave us this initial value information. They're saying, hey, if you plug in a 0 in for the first derivative, if you plug in a 1, they should equal each other. So to figure out what that constant c is, I'm going to plug in the information they gave us. 1 in for x. And there's that c that we don't know yet. So if I simplify, 1 to the 4th power is 1, so 1 times 1/4 is 1/4. And then 1 squared is 1, 1 times 4 is 4. So we can combine those. So negative 4 plus 9 makes 5, 5 and 1/4. So I'd subtract that 5 and 1/4 from both sides, but usually we like improper fractions. So that's negative 21 over 4 is an improper fraction. So that's our constant c that needs to go here. It's minus 21 over 4. That way, if I was to take a derivative, I'd get this. And if I was to plug in 1 in for x, I'd get out 0 in for y for the first derivative. That's our first derivative. To find out the original function, to find out what f of x is, we do the same thing, except now we're looking at the first derivative. So if I was to take a derivative of the function f of x, I need to have x to the 4th power. That means I've got to lead this off with x to the 5th power. And when you take a derivative, the power goes down by 1. And we'll figure out what that coefficient is in just a second. So in the first derivative, we have a power of 2. That means the original function needs to have a power of 1. We've got a power of 1. That means in the original function, we need to have some sort of power of 2. And then we have no power of x. That's x to the 0 power. So we better have x to the 1st power. That way I take a derivative, we have to have that. The question is, what are the coefficients that need to go here? So think about what will happen when you take a derivative. You're going to come down and multiply by 5. So I think we need to have the 1/4 be left over. But since there's going to be a 5 that's going to come down and multiply, we'll also multiply by 1/5 over here. Right? Because the 5 that comes down and multiplies from a derivative will cancel out with this 1/5 and leave us with the 1/4 that we want. And then we have a 3 coming down here, so that means we need to multiply this by 4/3. Because 3 times 4/3, those will cross cancel, leave us with just the 4 coefficient that we want. Same thing here, we want 9/2. That way when you take the derivative, the 2 comes down and multiplies. And then down here we want a minus 21 over 4 without an x to the power. So we want to change this to be a minus sign and have it be 20 over 4. So this is, I'm going to clean this up. 1/4 times 1/5, that's 1/20th, x to the 5th, minus 4/3, x to the 3rd, plus 9/2, x squared, minus 21 over 4x, and then there's plus some constant c that we don't know for the same reason as above. So to find that constant c, you've got to plug in the initial value information. We plugged in 4 in for the y value, 1 for the x value. And so to save my hands from writing here, I'm going to plug in 1s for the x's, and forget about the cube, because 1 cubed is just 1. Okay, so we got to combine all those numbers. So we got 1/20th plus 4/3 plus 9/2 minus 21 over 4 plus c. So a whole bunch of common denominator work there. I don't know. 60, I think, is the common denominator. So we got 3 over 60 plus, we're going to multiply 20 to the top. No, that's not right. The bottom, yeah, 3 times 20, so 20 times 40. 20 times 4 makes 80 over 60. Yep, okay, that is right. And bottom, we can multiply the top and the bottom by 30. And over here, I should know probably what's 60 divided by 15. So multiplying 15 to the top and the bottom. So 315 on the top, 60 on the bottom. And now they have common denominators. We can add the numerators. So we got 38 over 60. So trying to get c by itself, so we want to subtract 38 over 60 from both sides. So this is 240 over 60 on the left, minus the 38 over 60 on the right, coming from the right side. That will get us our value for c. So it's 202 over 60, and you'd want to simplify that, whatever that fraction is. You'd plug that in for c here, and then you'd have your complete f of x. Look, I had a copying error. That's supposed to be a minus sign, so that's going to throw everything off here for our final answer. So when we combine the numerators, 3 subtract 80, not plus 80. And plus 270, subtract 315. So that's negative 122 over 60. So we're going to actually be adding 122 to both sides. Or 122 over 60 to both sides. So 240 plus 122, that's 362 over 60, which if you reduce by the top and the bottom at least by 2, then I get 181 over 30 for C. So sorry about that copying error.